Good morning, Rich Nass. I am the Executive Vice President, Open Systems Media. I lead the embedded IoT teams for embedded computing design. I'm here for this week's Embedded Executive podcast. This week, my embedded executive is Saul Jacobs. He is the Vice President and General Manager at Tadiran Batteries. How you doing, Saul?
Great. Thank you for inviting me.
My pleasure. So the reason I invited you is because a white paper crossed my desk the other day, and it said something about the need for a battery to last 40 years. Um, I know a little bit about batteries. They don't last for 40 years. So where are you going with this? You guys producing batteries that are really going to last for 40 years? And before we get into that, what's the space that would need a 40-year battery?
Well, I mean, a space can be, the amount, that's the amount of capacity you need, and that's how often you use your product, your device. But the truth is, yes, batteries can last that long. I mean, if you take into consideration that batteries lose from self-discharge probably more than, over time, over years' times, than the actual usage of your device. If you have a very, very low self-discharge, your battery can last. So, for example, if you have a battery that loses, let's say, like we have a 0.7% a year in self-discharge, after 40 years, you will still retain over 70% of your original capacity. And if you can work with your device that uses that 70% of capacity, then you have 40 years of operation.
So what sort of chemistry are you referring to?
We have a lithium thionyl chloride battery. It's a non-rechargeable battery made for long life and hazardous and difficult conditions.
How do you know that it's going to last that long? I mean, do you have batteries that have been around for 40 years?
Yes, we have. First of all, we do, because we keep batteries from every production lot on in the lab, still operating, for testing purposes. So we've been producing batteries for over 40 years. We have one example where about 15 or more years ago, a company that was making gas meters, automatic meter reading gas meters, pulled their devices out that the utility decided to change the meters, and we asked to get some of the batteries back, and they were still in operation after 28 years, and we figured there was enough juice in them to last over 30 something years.
That's
So we have
incredible.
them back from the field as well. Yeah.
Okay, so you talked about metering. What are some of these other applications? And I'm assuming that these have to be a one-time use battery because if it's non-rechargeable, once you use it, it's
Yes.
done.
Yeah, well, the battery and a lot of devices, the limitation is the battery life. If the battery would last longer, then the application of the device would last longer. And the metering is the big market for us right now. I mean, they have to be reliable. They have to work 20 years or more in the field in very harsh conditions of -40, -50 to over 80, depending where they are, C. And there are a lot of devices out there that have to be in locations where you can't get to them or that you can't open them. For example, the Easy Pass uses our battery in New York, the RFID toll tags. And even though you can touch them, you can't open them. They're not meant to be open. So the battery has to last over 12 years, for example, with them. And all kinds of sensors and devices in the Arctic. The data loggers that were making sure that the COVID vaccines were at -80 degrees C. With the shipments, had to use batteries like ours, which had to operate to -80 at that time, and so reliability is very important as well.
So you mentioned different environments. What does the extreme temperature do to the life of the battery?
Well, I mean, very high temperatures cause the battery to discharge more often, so which means it reduces the life. Very cold temperature makes the voltage drop. So when you pulse them, if the voltage is not there, the battery will just not operate, will not be able to supply the power needed.
Okay, and are you talking about small amounts of power? I mean, you mentioned Easy Pass. Is that sort of the sweet spot?
Well, the point is nowadays, one of the reasons that many devices can be battery operated today, where they couldn't years ago, I mean, there are two reasons. One is that there are many different type of protocols and communications set up, such as cellular, satellite, LoRa, Zigbee, things like that, which can allow for low power operation. Another one is these devices do not work continuously. They tend to sleep most of the time, wake up every once in a while, take a reading and send out a pulse with communications over one of those protocols. For example, meters do not have to be on continuously. They're usually on once an hour for microseconds, and they check to see if there's a leak or something like that. The Easy Pass is only is sleeping until you pass through a toll gate. So that's the beauty of these systems. They do not have to be on all the time.
So you're measuring in milliamp hours in most cases.
Or yes, and microamps, as a matter of fact. I mean, the pulses can be amps, many amps of pulses, but in microamp hours or seconds or however you want, because it's a very, very tiny amount of time.
Okay. Are there other chemistries that would also be suitable for this application?
Well, there are different types of lithium primary chemistries, some of them quite good, but they don't always work at cold and high temperatures. They might, instead of at minus 55, they'll work at minus 10. And instead of 80, they'll work to, plus 60 C. So it depends on what you need. And the self-discharge tends to be a little higher. I mean, our battery is specifically made for long life with low self-discharge.
Okay. Is Tadiran doing something different than its competitors in the space, or is a battery a battery?
No, the batteries are not a battery. I mean, there are a number of manufacturers who make this lithium thionyl chloride battery. But we've been making it, as I said, over 40 something years, and we put a lot of money into our research and development. And not all the batteries have the same internal construction or the same chemistry, exactly. And self-discharge changes. They can be anywhere from, like I said, 0.7% to 3%. And that's a big difference.
Right. Over time, for sure.
Yes.
So are your customers looking for better than what you're giving them? I mean, I know they always ask for more, but if you had a battery that lasted 80 years, would you have an immediate customer for that?
Well, we haven't found any devices that will work that long. I mean, usually the devices can be over. Sometimes the device can be finished. I mean, water meters, for example, the water meter, because of the flow of water over the propellers, tends to get less efficient over time because they're worn down. So past 20 years is not necessary, because at that point you lose enough water, it pays to spend the money and get a new meter. But there are new ultrasonic meters out there, have new moving parts, and they could last 80 years. They certainly can last for 40 years because they don't wear down. And there you could see perhaps someone putting in a very, very long life battery.
What about things that go into people? Are you guys working on that?
No, we decided, even that's the same chemistry, we do not personally, our company does not want to get involved in that part of the medical market. We are in the medical market, but not in anything that's implanted. There are people who make devices based on our chemistry.
Okay. You guys have to continue to innovate. What will a battery 2 years from now look? In what way will that battery look different from what is being produced today?
Well, we are continuously looking to be able to supply more and more power and a longer life with a smaller battery. So to reduce size and costs, we have over time, for example, we make something called a hybrid layer capacitor, which we attach onto our battery to supply pulses of amps, and we keep improving on that so that they can use smaller and smaller ones, which are much cheaper.
Okay. Where does all this R&D take place?
We have a company in Israel and a company in Germany.
And the manufacturing?
In Israel and Germany.
That's awesome. Okay.
Yeah.
Well, I certainly learned a lot here. When I saw 40-year battery, I said, nah, these guys are pulling my leg. And apparently it's for real.
It is.
Very good. Well, thank you, Sol. I appreciate you taking the time to educate me and the audience.
All right. Thank you very much. I appreciate the time.
That was Saul Jacobs. He is the Vice President General Manager at Tadiran Batteries, and I'm Rich Nass with Open Systems Media.